All right, we're going to look at practice exam. Before we go through some of the questions, just some things you should know when doing these tests. Make sure that you organize your work so that's very clear and the person correcting doesn't miss anything. Unsupported answers will not get full credit. You want to make sure if you're doing a problem, don't just put down what your calculator or graph on your calculator shows. You want to explain, show your work, do all that so you get full points. When possible, give exact answers. So if the answer comes out to be something like square root of 2, leave that as your answer, not the decimal approximation for that. Okay, so those are just some things to keep in mind when doing an exam. The first question on this exam is asking what is the domain of this function. Remember, the domain is the numbers you can put in for x. And on this one, the top is all real numbers. The bottom function, if it was just on its own, would also be all real numbers. But because that is in the denominator, we know we can't divide by 0. So the domain for this one, they were looking that it was all numbers besides 5. So you could write that as that interval notation, similar to this, with a union. That would have been full credit. Or you could have wrote that other notation where it's all x where x can't equal 5. Either they would have accepted either one of those, and it was for 5 points. Part B, compute the limit. So with the limit now, you're writing what's the limit as x goes to 5 of that function up there. One thing you should have noticed is we can factor that top out. So you should have factored this to x minus 5 and x plus 1. That allows us to cancel out here the x minus 5s. Now we get the limit as x approaches 5 of just x plus 1. And now you can plug in 5 to get your answer of 6. How this one was graded, the factoring, correct factoring was 4 points. The simplifying work in here was 4 points, and then final answer 2 points. Also though, if you forgot any of these limit notations on here, it was -1 for each missing limit notation. So make sure on the exam that you do write your limit notation until you actually start plugging in for that value. Part C on that problem, is there any vertical asymptotes? This one would not be a vertical asymptote. So the answer you should have had is no. That was 3 points, 3 of the 5 points. The reason that it's not a vertical asymptote, and you could have checked the graph, like use your calculator to graph, but you see that it's a hole. There's a hole at 5. Not an asymptote. Not a vertical asymptote. So something to that effect would have been the explanation of 2 points. We also know it wouldn't have been a vertical asymptote because the limit, if you approach 5 and it was a asymptote, there should be infinity or negative infinity, so you could have written something about that as well. Part D, is this graph continuous at 5? Also should have answered no on that one. That was 1 of the 5 points. Reason is our definition of continuous here. If something's continuous, we know that the limit as x approaches 5 for this function should equal f of 5. And what we got from the previous problem is that limit as you approach 5 for this function ended up being 6 from part B. But we know from part A that f of 5 doesn't exist here. So that that's how we know it's not continuous, because it's not defined there. So that was 3 points. For the last point, they did say explain how you could modify f of x to make it continuous. One way you could do that is make this like a piecewise function. So the function that we had from the beginning of the problem was we're dealing with this function. And that's good everywhere except where x is 5. So we don't want that being 5 there. If it were continuous right at x equals 5, we know the value should come out from part B, our limit, to equal 6. So we'd want to define that at 6. Now that would make it continuous. So having something like that would give you the final point on that problem. All right, question 2. The functions, 2 graphs are shown here for f and g. They want you to compute the limits and explain why they do or do not exist. For the first one there, what's the limit as we approach 2? You can see from here that both sides are not approaching the same thing. So then you'd want to show both sides here, show the limit as we approach 2 from the left of this function equals 0. That's the y value over here. Also show what's the limit as we approach 2 from the right. That's approaching a y value of 1. And so what we'd want to say on this one then is that the limit as we approach 2 of this function does not exist. And the reason would be that both of these sides are not the same. If there's a limit, both of these should be equal, and they are not. And so that's what they're looking for there. On this one, the scoring was 3 points for showing both the left and right hand limit, 2 points for saying it doesn't exist, 2 points for the definition. Part B, explain if this limit exists. Now this is a combination of f and g together. But remember, to just say if something has a limit, you still want to show left and right side. So let's do the same thing we did in the last one. What is this as we approach the left of these two being added together? Well, from the left, we already know f of x equals 0. From the left, g of x, the y value looks like it's 1. And so combined together, this limit from the left is going to equal 1. If we do the same thing from the right now, f of x is approaching 1 from the right. On g, g of x is approaching 0. Combined, that's approaching 1. So on here, since they match, this one then does have the limit. The limit as x approaches 2 for this addition of f and g should equal 1. This one, 3 points for each the left and right limit, and then 4 points for the answer of saying 1. On part C, now they're multiplying the functions, but again, you want to show left and right. So what is this as you approach from the left of f times g? That would be on f, again, 0. And on the right, or on g, that's 1. So that multiplies to 0. Now show it from the right. And And we know f from the right is going to be 1. G from the right is 0. Multiplied that 0. Since they match, this one also has a limit of this combined multiplication of these two functions. So we'd say that this is 0. So same scoring as part B, 3 points for each of those, 4 points for the final answer. All right, problem 3 says, suppose that this function s represents the position of a particle at time t. Find the average of velocity during the time from 1 to 3. Show your work how you get the final answer. So on this one, average velocity or average rate of change is talking about slope. So to find average velocity here, since we're doing position, it's position over time. So we want to show what's s at 3 minus s at 1 all over the time difference of 3 minus 1. That statement was 5 of the points. Now plugging in the correct values is next. So somewhere you want to figure out what those are. I'm going to do it off on the side here. So s at 3. That's just plugging 3 in here for all the t's. So t cubed plus 2 times 3 squared minus 3. If you solve that out, it should be 42. Do the same with 1 now. 1 cubed plus 2 times 1 squared minus 1. That one's going to equal 2. So now if you substitute in the values, you got 42 minus 2. 3 minus 1 on the bottom is 2. And that should simplify to 20. So on this one, 2 points for the correct values there, 2 points for the final answer. On part B, write down a limit which represents the instantaneous velocity of the particle at time t. You should evaluate any functions in your limit, so they want you to replace or substitute, but you should not simplify your expression, so you don't need to evaluate the limit. All right, so doing this one, we know they even tell you right in the problem, you need to do a limit with instantaneous velocity. We've done that before. So this is going to be the limit as our little bit extra h approaches 0. And we should be setting up something very similar to our average velocity here, except now we're just doing the time here that they want us to do that at, which is 3 plus that little bit extra h. So this should be s at 3 plus that little bit h minus s at 3 all over those same 2 times of 3 plus h minus 3. So it's just instead of using 2 different times like 3 and 1, we're trying to say 3 and then 3 plus a little bit as that little bit goes to 0. So that's kind of the goal we were looking for there. Having that statement was 8 points. Then they did want you, they said substitute in any function. So we did have to substitute in here. On this one, and they said not to simplify, but I mean, it's pretty easy simplifying to see that 3 minus 3 is going to be 0. So we're going to get limit as h approaches 0 then of just h on bottom here. We know to get s at 3 plus h, we want to plug that in for all the values here. So it should be 3 plus h cubed plus 2 times 3 plus h squared minus 3 plus h. So that's all that one. Now we got to plug in for s of 3. We've already figured that out from the part A. That comes out to be 42. And you didn't have to go any farther than this because they said you do not need to simplify, just substitute in. That was 4 points of the problem. So that's what they were looking for on that. There was that other limit definition of derivative you could also have used. we didn't spend as much time on that one, but could still get full credit. That other limit definition is the one where it says limit as whatever your variable here is. In this case, it's time approaches your value in the problem A, and then it was s at t minus s at a over t minus a. So in this problem, since it's, what is it approaching 3, you would have wanted to do, what's the limit as t approaches 3 of s at t minus s at 3 over t minus 3. So just like in the other one, if you had that, that was 8 points. Then you had to substitute in. So if you substitute it in here, s of t would be the function that we had, so t cubed plus 2t squared minus t. S of 3 is still 42 like we had from part A over t minus 3. So that could have been a different way of doing it. That's 4 points. You didn't need both of these, you just needed one or the other for full credit. All right, final problem. Compute this limit. You got to notice it is going to infinity here. We don't have a great way of doing this one because really that's kind of like infinite. All this stuff would go to infinity, but this is infinity, and infinity minus infinity, that's hard to figure out. We don't know what that necessarily goes to depending on which is getting bigger or smaller faster. It doesn't mean it's 0. So we need a way of evaluating this one. One thing that you should have seen is that there is a square root in this one. So almost all the time with those ones with a radical, you want to use conjugate, and that was no different on this one. So we want to multiply this one by its conjugate. The conjugate being same stuff, same radical here. We want that 4x, but we want to switch the sign, not the one in the square root, the one in between these two terms to the opposite, so plus. But if we multiply the top by that, then we have to also have this in the denominator, so it's really like we're multiplying by 1. We don't want to change the value, we just want to change the way it looks. So you needed to multiply by conjugate. That was 6 points if you multiplied by the conjugate. All right, next step, then we want to continue our limit notation just like we did early on that limit problem. When we multiply these now by the conjugate, that radical times the radical is just the stuff under the radical. The outside terms and the inside terms are going to cancel out. That always happens with the conjugate. When we multiply these last two terms now, it's going to be a negative, and 4x times 4x would be 16x squared. All over, now this becomes a fraction because we multiplied by that conjugate over itself. Square root 16x squared minus 7x plus 4x. Now, right now that maybe doesn't seem like it helped, but we do have these two terms now that cancel out. So now we got limit. As x approaches infinity, on top it's just going to be negative 7x. Let's see what we can do on the bottom of that. On the bottom, one thing it looks like we could do here is we could pull out or factor out this term because that is a perfect square and we could get that out of the radical. So let's factor out a 16x squared then. So what would be left is 1 from that first term minus, if we factored 16x squared from 7x, that means really like we just divide it by 16x squared. Okay, let's keep going here. So now we could separate these two into 2 square roots. multiply to each other, so it'd be square root of 16x squared times square root of this remaining stuff. And I'm going to cancel one of those x's here since we got x on top and 2 on bottom. Let's cancel one of those, so it'd just be 7 over 16x plus, I forgot the x there, plus 4x. And then square root of 16x squared, that would just be 4x here. Okay, one more thing I'm going to do now before we do this limit as we go to infinity. I see that we have a 4x here and a 4x here. So we could factor that out since both terms have that. So limit as we go to infinity would be negative 7x over, I'm going to factor out that 4x. And the reason I want to do that is eventually I want to cancel some x's here. And so what remains then is the square root term. And if I factored an x out of this, or 4x out of this one, it'd just be plus 1. Okay, so now we've got to this step. Now what we want to do is multiply by the reciprocal, the biggest power in the denominator. Biggest power in the denominator is that x to the first. So we want to multiply by 1 over x to the top and 1 over x to the bottom. Okay, having that in there was 6 points of doing that step. And so now our limit on top, if we multiply by 1 over x, is just negative 7. On the bottom, that's going to cancel this x right here, so just be 4. And then we got these terms left. Now we should be able to apply this limit as we go to infinity. This term right here, since x is bigger in the denominator, we know as we go to infinity, that's going to go to 0. And so if we apply the limit now, I don't need to write the limit notation anymore because I'm applying the limit. Be negative 7 over 4 times the square root of 1 minus 0 plus 1. So now we just got to finish simplifying there. Square root of 1 minus 0 is 1, square root of 1 is 1, so now we got that. 1 plus 1 is 2, so now we got negative 7 times 4 times 2, which would be negative 7/8. That is what you should have come up with for the answer. That final answer is 3. All this simplifying work here was 3, and all this algebra simplifying kind of up here was also 3. So that's how that one was scored to, and I missed the last, the substituting in and getting this to be 0 was also 3. So the evaluation there was 3. So that's where the points came for that one. One suggestion on a problem like this, you could definitely graph that out and see as you go to very large numbers, is that approaching this negative 7/8 value, and you should see that it is. So you can check it with your calculator, but you do need to show this work, the algebraic reasoning, to get the full credit on that problem. But definitely you can use calculator to check to make sure your answer is correct. It's a good way to, if you have time, make sure that you are doing it correctly.